Hello, I'm Ian Evans. Today we're going to have a look at the Connected Components Workbench software from Rockwell, which used in conjunction with the Allen Bradley controllers. We've got a quick tips page up here. I just closed that. Now, the first thing we need to do is to tell the software what controller we're going to be connecting to via the USB cable. So when I click down in the catalog on the controllers, you're going to have a whole selection of a whole range of PLCs there, large, small, and what we're going to be using today, which is the Smart Relay. So in the Micro 810 family, I select the 2080 LC1012QWB, and I drag that over, and I can drop that into the tree project organizer here. I'm going to select go back to Major Revision 1 here, because that's how our controllers are currently set up. Okay, that drops that tree into the project organizer. So there's our project tree. If I double click on the Micro 810, brings up the connection screen. I can upload, download, go to program mode, go to run mode, connect and so forth via the USB cable. It's got some information down here. There's some manuals, help, some information on the controller. If I right mouse click here on the LCD screen, I can actually add the LCD screen, which shows how our controllers are set up with the manual input or manual interface. So we can manually input through via that module. We can also observe the current status of the PLC of the Smart Relay, as far as where the inputs and outputs are on and off. Next, we need to create a programming module. So on programs, if I right mouse click, I can add. Now I can add structured text, ladder diagram, or function blocks. Structured text to high level language, which is the most economical way to program, but you'll need more training. Function blocks, function block diagrams. Again, they are a quick way to program, but you need further training on those. Ladder diagram, which we'll use today, we'll select the ladder diagram. As electricians, we understand circuit diagrams, so ladder logic is very similar. Now, nothing changed here on the screen, but except for my program tree here, it's now included my programming module here. If I right mouse click on there, I can rename that, so I can call that Project 1. Okay, and then I can double click and bring up my programming module. Now, because I've told the software what controller I'm going to use and also how we're going to program today, it provides me with the appropriate toolbox to use with it. Now, I've got a rung. If I want to include an extra rung, I can drag that over. I've got return and jump, which are a couple of advanced programming functions, which we won't be using today. There's things like a branch, a parallel branch. What we call as just an output is a direct coil. The inverse of that, the reverse coil. A couple of special functions, set coil, used in conjunction with a reset coil. You can set and reset. It's got some what they call pulse rising edge, pulse falling edge, both coil and contacts. They're special features where they look for the rising edge of the input and the falling edge of the input. What we see is what we understand as a normally open contact is here is a direct contact, and a normally closed contact is a reverse contact. We'll be looking at at a timer and a counter also today, and we'll use the block for that. So what I'll do now is I'll just I'll left mouse click on the direct contact, drag it over, drop it into my first rung of my program. Okay, if I click on the input-output here, I've got input-output Micro 810. It gives me the listing of my 4 outputs, my relay outputs, 0, 0 to 03, and my 8 inputs. So it's DO for output and DI for input. So 00 through to 07 is my 8 inputs. I'll select my first input. I'll give it a name. My start. I'll just give it a start button. Okay, and what it does is it addresses that element there to say that if I put a 24 volt signal onto my first input 00, it'll tell the logic to come into the logic here and close that element of the rung. Okay, let's put a coil, a direct coil. So I'll drag a coil up to here and drop that in. Now I could use my any of my outputs here, but usually when you're programming, we use what we call internal relays. Okay, by using internal relays, we're not wasting our physical outputs. Okay, so I'm just going to call this internal one. So that's just my internal relay. Okay. Now, what I'll do now is I'm going to drag across a branch. So I'm going to drag this branch over here, drop it on top, and it gives me my parallel branch there. Because what I'll do if I'm going to say just set up a start-stop function here, I'll need a hold-in contact. Okay, so I'll bring my direct contact over. So I'll drag a direct contact over, drop it in. Okay, and I'm going to use my internal one. So I'm going to use the internal one internal relay here. So what that is, it's a contact off that internal relay. So it acts exactly the same as far as your logic goes. It acts exactly the same as it would do with with an external relay output. But again, like I said before, it's so we don't waste our external relay the outputs, because we only have 4 of them. Now the logic here is very similar in terms of our circuit diagrams. So we have all the action elements in this part of the circuit. For the outputs, we only have the one output for any rung. So we can't put outputs in series with each other, as you would do with a circuit diagram. You wouldn't have coils, so you can picture these as the coils of a relay. So they don't go in series. So if you need extra logic, you can build a new line below and put a new internal relay in. Okay, let's put another contact. Let's put a stop button in as well. So that'll have to be an actual input. So for a stop, okay, you'll also notice for my stop button here, I'm using a normally open contact. I don't use normally closed like I do with my normal circuit diagram. The reason for is the actual stop button in the field takes care of that stop function, and that feeds a closed function to the logic. So when we switch this on, and our normally closed stop button in the field will signal to this to actually close. So we all our logic, same with overloads and so forth, will show us with a normally open. So that's the difference between our relay logic and our circuit diagram, the logic we apply to our circuit diagrams. Okay, now we'll put another rung in. So I'll just drag a rung over, drop that in. Oh, what I can do here too, so I can put descriptors into each of my lines here, and I can actually write information up here too. So this is the start of our program. So I can also in this section here in the blocks, I can actually type information in here too. This can be important if you're when programming, to actually explain what's actually happening in the program. It's also good too for if you come in to make any changes, if you're doing any upgrades putting any fixes into the program, it tells other people what you've actually done. So it's good to always have put whatever information that's required onto the program. Okay, so let's take another direct contact over here. Okay, I can use the variable selector here, or I can click on. If I click here, I get a drop down list, and I can also come down and select and actually address that particular element there. So again, I'm just saying what's happening here then is just simply when I press my start button, as long as my stop button's closed, the internal relay will close, and that internal contact will close, holding that in when I release my start. And so the internal contact here will close, and what we'll do now is I'll bring a block over. Okay, and now my block, so what I'm going to do now is going to put a timer in. So I'm going to scroll down. You can see there's a large range of function blocks here. So there's a lot of function blocks. Again, you'll need training to actually understand how to use them, So what we're going to look for now is a timer, time on delay. So a simple time on delay timer. So I'll click on that and go OK, and it gives me a time on delay timer. Okay. Now what I need to do is I click in this box here, and I need to tell it it's going to be a T for time. Put a hash there, and then I say, okay, I'll give it, say, 5 seconds. Now 5S is 5 seconds. 5, if I put an M in there, it's minutes. H for hours, and so forth. Okay, if you notice there's a little exclamation mark down in the right-hand corner of the box here until you actually put your you address the block, and that tells you that it needs something in that block. Okay, so otherwise it's sort of faulty. So that's our predetermined time. So that'll run. That means this timer, when this closes, that'll run for 5 seconds. So the elapsed time will show the elapsed time. It'll count that 5 seconds out, and then it'll turn this Q, which is the output of this timer. It'll turn that on. All right. So what we'll need then is another coil. So we'll need another direct coil here. Okay, so this time I'm gonna turn on an actual relay. Okay, so I'm going to call this my output 1. Okay, so I've now selected my the first relay output, output 1 there. Will turn on 5 seconds after I press my start button. Okay, so we've just carried out a simple function there of a start stop with a timed output. All right, let's drag another branch in. Oh, sorry. That was a rung I was trying to drag in there, sorry. Drag another rung in. And again, we need to be labeling these. We need to be putting in information and labeling them as we go. As I'm just showing you how to put different elements into here. It's not actually a working program, of course. Okay, so what I'll show you this time is how we'll do a counter. So on many times we want to have something that provides counting for us. So you may want a situation where in a program that it's counting the number of times an overload will trip. So if the overload trips too many times, it'll then signal to the controller and say, okay, don't let the motor run for another hour or so because it's been started too many times this hour, and so forth, and all those sorts of things. So many times for use of counters, They can be used for counters. That use handy one too for doing a set reset function for doing standby and duty cycle pumps and so forth. So whole range of applications for counters. They're endless really. But we'll just see how we actually put a counter in. Okay, so what I'll do is I'll just put a contact in. So we'll put a direct contact here, and I'll use another contact. I'll use another input. So I'll just call this my count input. So every time this input operates, my counter will count. Okay, so I'll drag the block over again. Now this time I'm going to go look for a counter. So it's in alphabetical order. So I come down looking for C for count. Okay, so there's my counter up. See, I've got count down, I've got counter up, down, so a whole range of different functions there. So I'll just choose my standard counter up. Okay, and so what I'll do is I'll also put another coil in. So direct coil. I'll drag my coil in. So when my counter actuates, it'll actually go out and do something. So there's my output 2. Okay, so it's just allocated to that output. It'll go and so whatever we determined our counter is going to do for us, it'll go and turn that relay on. Okay, now so our counter. So again, we have got our exclamation marks here, showing us we need to put something into these boxes. Okay, so if I click on there, and I'm just going to put the number 4 in. So that's going to tell me now my predetermined value is 4. So so it wants to see 4 counts. So it means I've got to turn my input on and off 4 times. So I'll switch my input on and off 4 times, and then my counter will turning on this output. Okay, the value, the actual counter value, will show you. So at any point you look at the program, you can see the actual value of the counter. Okay, now the reset, I'll click into here, and what I need something to reset. So I could use an input. I could use another one of my inputs to actually come in and reset the counter. But a common way to actually do it is to actually use the actual output. So output 2 is to use its own output here. So to say that when it actually counts and does its job, it'll then switch itself off. So it'll go off, do its job, and reset itself. But again, I can use to reset that. I'm just doing this for the exercise just to show you. So this will go through, do 4 counts, go off. It'll close my my second output. It'll then reset itself and reset, ready to start counting again. Okay, then at this point we need to come up to here and build, and click on build, and what this does now, it goes through and confirms the program down here in the output. It's got you can watch the build started. Okay, it's now going through and checking the program and saying there's no errors, no warnings, and okay, build end. Okay, so build 1 succeeded, 0 failed, and so forth. So there's no error message. So what it's saying, there's no error messages there. So it usually comes up and gives you error messages, which you can click on. It'll tell you where any particular fault is in the program. Okay, so that's just a quick that's just an introduction to how to program the elements in there. This is the first part of it. In the second video, we'll have a look at actually connecting to the controller itself via the USB cable. Okay, well, thank you for listening.